In this video, we're going to look at rationalising the denominator. So anytime we have a fraction and it has a surd at the bottom, because surds are irrational numbers, then this has an irrational denominator. So when it says rationalise the denominator, basically what it's saying is get rid of the square root symbol from the bottom of the fraction. Now a couple of things are going to come in really handy here. The first thing to understand, and it should be no surprise to you, is that when you multiply something by 1, it does not change the value of it. So 5 times 1 would remain as 5. X times 1 would remain as x, and so on. The other thing we need to be able to think about is the number 1 itself can be written in an infinite number of ways. Okay, so basically if I want to write the number 1, I can do it by writing any number at the top of a fraction as long as the number at the bottom of the fraction is the same. So 1 could be written as 5 divided by 5. In other words, 5 divided by 5, this whole thing here is just a fancy way of writing 1. I could write it as x over x, that again is equal to 1. I could write it as root 2 over root 2. Okay, and again, because the top and the bottom are the same, then how many root 2's go into root 2? Well, that's 1. So this, and this are all just different ways of writing the number 1. And the very last thing we're going to have to know to do this is that when I multiply root a by root a, it gives me just a. Now this makes sense if we think about this as being the square root of a times itself. So the square root of a squared. Now because the square root and the square here are inverse to each other, the square cancels out the square root. So what we'd end up with is the square root symbol gets cancelled along with the square, and we're just left with the a. Now you could think about that with whole numbers as well. So for instance, if I take the square root of 9 times the square root of 9, that's basically 3 times 3, which is just 9. So here, that rule, root a times root a is a, root 9 times root 9 is 9. And we can use that to help us here as well. Now we'll look at a few examples. So in this first example here, we have 1 over root 2. Now it currently has an irrational denominator. So I'm being asked to rationalise the denominator. So I want to get rid of this square root of 2 from the bottom. So specifically, I want to get rid of the square root symbol. So the way I'm going to do that is I'm going to multiply by 1. But I'm not going to write like this. I'm not going to write times 1. What I'm going to do is I'm going to write 1 in a particular way. So because I want to get rid of this square root of 2, I'm going to write the number as the square root of 2 over the square root of 2. Now, this bit here is just 1. So what I'm doing here is I'm multiplying by 1. So I'm not going to change the value of this fraction, because multiplying by 1 doesn't change the value, but this will help me change its appearance, and that's all I'm really interested in doing. So when we multiply fractions, top times top, so this is 1 times root 2, which is just root 2, and then bottom times bottom, and remember root 2 times root 2 is just going to be 2, so that is over 2. Okay, so remember that last part, root 2 times root 2, anytime we have root a times root a, it's just a, so root 2 times root 2 is just 2. And what you'll see there is now I just have 2 on the denominator, and 2 is a rational number. In other words, there's no square root symbol here anymore. So I've done what I've been asked to do there, which is to rationalise the denominator. In example B here, we've got 3 over 2 root 7. Now the bit of this that I want to deal with is the root 7. Remember, I'm interested in getting rid of this square root. So again, I'm going to multiply by 1, but I'm going to write 1 in a specific way. I want to get rid of this root 7, so I'm going to write 1 as root 7 over root 7. And then top times top, 3 times root 7 is 3 root 7. And then bottom times bottom, well, I've only got this 2 here. This doesn't have a rational part, so it's 2 is going to go on the bottom. And then remember, root 7 times root 7 is just going to be 7. So it's 2 times 7 on the bottom. And then I'm just going to quickly simplify that to 3 root 7 and over 14. The 2 times the 7 can go together. Now, a couple of things that we want to check here is we want to check, can the 3 over 14 be simplified further? In this case it can't. And also, can the root 7 be simplified further? But there is no square number other than 1 that goes in 7, so that's already simplified. Let's have a look at another example. So in this example, I'm asked to write 16 over root 12 with a rational denominator, but this also says in simplest form, which implies that once I've rationalised the denominator, I'm going to have to maybe think about some simplification. So let's make a start on this. We'll write out the 16 over root 12 first. and we'll have a look at the denominator I'm trying to get the square root off of. So I want to get rid of this square root on the 12. So because that's root 12, I'm going to multiply by root 12 over root 12. Now remember, this is just, again, a fancy way of writing 1. So it's not going to change the value of this when I multiply by 1, but it will help me change the appearance. Top and bottom here should always be the same to create that 1. Now, 16 times root 12 is just going to be 16 lots of root 12. And remember, root 12 times root 12, that's simply going to be 12. Now in this question, that is me rationalising the denominator, so this is now no longer got the square root, so that part's done. But the question says in simplest form. Now we need to be really careful when we're simplifying surds, because there's a couple of things that we could potentially simplify. So I've got to check, can the 16 over 12 part be simplified like we would normally simplify a fraction? But I also need to check, can the surd part be simplified any further? So can this root 12 be simplified? Let's start off with the 16 over 12 here. So 16 over 12 definitely can be simplified. They're both in the 4 times table. So that can be simplified to 4 over 3. So 16 over 12 goes to 4 over 3. And then that root 12 I'm going to put back on the top there. And then because I've multiplied this part, I can then check, can I multiply the root 12 part here? So the square root of 12, there is a square number that goes into 12. It's 4. So that's 4 times root 4 root 3, so the root 4 root 3 is in place of the root 12, all over 3, which is 4 times 2 root 3 over 3, and I've run out of space here, so I'm going to bring that up, which is equal to 8 root 3 all over 3. So when you're simplifying these, just bear in mind that you need to keep going back and checking, can I simplify the numbers here, the rational parts, and can I simplify the surd? Okay, so at the very end, I finished that, but let's just double check. Can I simplify 8 over 3? No. Can I simplify root 3? No. So that's the question done. So I'm going to give you a chance to try these yourself now. So if you want to pause the video here, try the 2 questions, and then quickly we'll go over them to check you can do them. Okay, pause the video now. Right, and now we'll go through them. So this one here, first of all, we've got 3 over root 5. So what I want to do is I want to multiply by, and I want to get rid of the square root on the bottom, which is root 5 at the moment, so I'm going to multiply by root 5 over root 5. It really is just as simple as look at the surd you want to get rid of, then multiply by that over itself. Okay, so top times top is 3 root 5, bottom times bottom, remember root 5 times root 5 is just going to be 5. Now, it says here simplify if possible, so 3 over 5, that doesn't simplify any further, and there's no square number other than 1 that goes into 5, so that's already simplified as well. So this first one is done. The next one here, 21 over root 7, again, I want to get rid of this square root above the 7, so I'm going to take that root 7 and I'm going to create a fraction to multiply by, which is just root 7 over root 7. So I'm multiplying by 1, remember here, not changing the value, just the appearance. So 21 times root 7 is 21 root 7, and then remember root 7 times root 7 is just 7, so that's all over 7. And again, we're looking to simplify if possible, so I'm going to check, can the root 7 be simplified any further? Now there's no square number other than 1 that goes into 7, so that's in a simplest form already. And then look outside here, there's 21 over 7, well that can be simplified. So that can actually simplify down just to 3. 21 divided by 7 is 3, so that's 3 lots of root 7. And that's it.